Hello students, welcome back. So far, Factory Frenzy is coming along pretty good, but there's one glaring problem. On really slow computers, our game is going to be experienced a little bit slower. And on fast computers, it's going to be experienced faster. Like the packages are just going to move faster on the conveyor belt on a fast computer, and they're going to move slower on a slow computer. That's pretty inconsistent, and inconsistencies is not something that we are aiming for. No matter this actual speed of the computer, we want those packages to move across the conveyor belt at the same rate. And the problem is that so far, everything that we've done in our game has been built around a frame-based system. We are processing our game every single frame. And some computers might just be able to run more frames per second than other computers. So what we need to do is switch from a frame-based system to a time-based system and process our game loops not by frames, but by some unit of seconds. Because 1 second is 1 second, no matter if it's on a slow computer or a fast computer. And then once we have this measurement of time in place, we'll use that time to help scale the difficulty of our game. Our game should get incrementally harder and harder and harder the longer we play it. So the longer we play that game, as time advances, we're going to scale our difficulty. And we're going to do that using something known as a difficulty ramp. So let's head to our computer screen and we'll dive right into this lesson. So I have lesson 5 for Factory Frenzy open here in vscode.dev, our delta time and difficulty ramp lesson. I'm going to minimize this folder though, and we are going to open it directly in our browser. So lesson number 5, lesson 5's starter. And let's take a look and see what we've got here to begin with. So I'll press enter to begin, and let's see. Oh my gosh. There are so many packages coming my way, so many widgets. I cannot process them. I don't know, guys. Everything is broken. Everything. Like the packages are flying so fast. I mean, look at our conveyor belt. I don't even see the lines of the conveyor belt anymore. My player movement system, I can move up and down okay, but horizontally, as soon as I tap the key, I just shoot across the conveyor belt. So movement is broken. Things are not good. But one of the things that is kind of good is if I just pause the game here, it looks like I got some new information in my HUD. It says deadline. 30 seconds. So we might have like 30 seconds to successfully fulfill our order, and hopefully we might like count down from there. But right now, any system that was using the frame-based movement, like the conveyor belts moving or our packages moving or even our player moving, this is just broken beyond belief. So we got to fix it. We got to head back to the computer screen and we have to work on our lessons here. So mission number 1, it says add the delta time variable and clamp it in our draw function. All right, so what exactly is delta time? Well, if I search for mission 1, we'll go to our tag here, mission 1 in our setup. It says delta time is the number of milliseconds since the last frame has been processed. So delta time is a built-in variable that we can use. It's the number of milliseconds since the last frame has occurred. All right, so a frame processes, the next frame starts, and maybe it takes 0.002 seconds for that frame. It's that time interval. I'm sorry, maybe it takes like 2 milliseconds. It's that time interval in milliseconds, but we don't want milliseconds. We want to convert it to seconds. So we're going to create our own variable called dt, and we're going to set it equal to delta time, the delta time variable, divided by 1,000, because there are 1,000 milliseconds in a second. But there's a problem here. If I'm playing my game, right? I'm playing my game. Okay, so I'm going to play my game. Zoop, 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 zoop. I play my game, and then I go away from the game for a little bit. 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. When I come back, the time interval will spike. Delta time will get super big because I've been away from the game for so long. And that huge spike could cause some weird gameplay issues. So what we want to do is we want to sort of like cap this dt variable that we're going to use at a highest value. Now, this is always confusing to me, but to cap this at its highest value, I'm actually going to use a function called the min function. And we're going to put something in here, and the minimum function is going to pick the smaller of the two. So I'm going to pick like 0.033, and then I'll put delta time divided by 1,000. So if delta time, if it were 5,000 milliseconds, 5,000 divided by 1,000 is 5 seconds, we're going to pick the minimum of 5 seconds or 0.033. So we're going to pick 0.033. So that is essentially like our capped point for the amount of time that we'll process in between each and every frame. So now that we have that DT, we can use it in mission number 2. It says mission number 2, runtime timer, update runtime seconds using DT. Pass DT to the required functions. Okay, I think we should probably, it looks like we got a new variable here. We should probably go scan like our student edit zone to see what are we working with in this video. So if I scroll down, all right, we've got some, if you look here, it looks, look at our player speed. It's no longer 5 pixels per frame. Instead, it says DT converted. 5 pixels per frame at 60 frames per second is roughly 300 pixels per second. So we're expressing the player's speed no longer in how many frames or how many pixels we want to move per frame. If we were at 5 pixels per frame and we assume we're moving at 60 frames per second, then we should move 300 pixels every second. So we've changed the player's speed. All right. And it looks like we've commented out our belt's scroll speed. All right. And we've also commented out our widget spawn frame. Well, that's because those things are going to get controlled by our difficulty ramp. As our game goes on, the difficulty is going to increase, and this belt speed is going to get faster, and our widgets are going to spawn faster. So if we look here in mission 5, it looks like we target all of those variables in a difficulty ramp. So we'll come back and look at those in a little while. If I keep going down, what else do we got? We've got new gameplay variables. We've got, all right, some stuff for our ramp, so we'll look at those. And then we've got runtime seconds and deadline seconds. So we're going to keep track of how long our game is running for, and we're going to keep track of the deadline that we have. So right here, it's like set to 30 seconds. And I think there was a constant here for that. Let's just take a look. Yeah, deadline seconds start is set to 30. Okay, so now we have an idea of what we're working with in this system. Let's come back to runtime timer, and let's increase our runtime timer using DT. And we're going to pass that DT to our required functions. So how long has our game been running for? Well, it's been running for DT seconds. So remember, draw runs every single frame of our game. Every single frame, we're getting how much time it took for that frame to process. And so I'm going to add that time to our variable runtime seconds. Now, some of these functions that we use to update our systems are going to require that time interval in order to properly work. So let's just scroll through and let's see what might need that delta time variable. So reset games to defaults, nope. Update ramp values, that's a new function. It looks like we got to get in there. We will. Okay, update deadline. That requires DT. It looks like we're taking our deadline seconds variable and we're subtracting our time interval. So it's going to count it down. Update belts needs DT. Update player needs DT. Update widgets needs DT. All right, so that's pretty good. So we got to pass that in, and it looks like that's about it. Okay, so let's go back up to our draw function and let's give those functions access to this delta time variable. So update deadline needs it, DT. And as soon as we give it that time, let's just watch what happens to our deadline here. Now it knows time. It's still broken. Do I got to click out of it? Let's just see. If I click out of it. Now, there we go. It's updating time properly. Of course, we're fulfilling orders at lightning quick speed because other things are broken. So every time we fulfill an order, it looks like we reset that deadline back to 30 seconds. So let's give our belts DT. We said the belts need DT. Is that going to fix anything? Ooh, now our belts are moving at their normal speed, but our packages are completely wonky. So let's set our player and our widgets to have DT as well. Does that fix those systems? Negative. Those systems are not yet fixed. So hopefully we got to go in there and use this DT value that we just passed in. So let's head to mission number 3. And mission number 3 finds us in the player's update, the update player function. So the update player function, it says we now have to apply delta time to our player movement. We are going to convert X movement from frame-based to time-based motion. If you remember, we said we converted the player's speed from 5 pixels per frame to 300 pixels per second. But we're not moving 1 second here. We're moving by dt amount of seconds, however little time has elapsed since the last frame was processed. So how do we relate the player's position to their velocity and time? Well, I'm going to just bring up a whiteboard here, and we're just going to jot down a pretty standard equation of motion that says average speed is equal to how far you go in some interval of time. V bar is equal to d over t. And so if you look down here, we are solving for the position of the player, player.x. So I'm going to solve for our position right here, solving for d. Well, right now it's being divided by t. So to undo that division, I'll multiply both sides by t. Those t's cancel, and I get that the distance, or the position of our player, is going to equal its average speed times our time interval. And so we have the distance, that's player.x, p.x. We have our speed, that's player speed. We just need to multiply that speed by some time interval. Well, how much time are we moving through? We're moving through dt. That's the amount of time that has elapsed since the last frame has occurred. So we're going to take this line right here, that equation of motion, and we need to multiply our speed by dt. In doing that right there, our player system should be fixed. Our player should now move normally. Hey, and they do. All right. So I'm assuming we got to do something similar for our widgets, because our widgets are moving way too fast. So let's check out mission number 4. Mission number 4, it says widget timers. Apply delta time to the widget spawn timer and widget movement. Convert widget spawning and travel to time-based behavior. So I think we got to do 2 things in here. Ooh, that's kind of interesting. We got to do 2 things. We got to apply dt to their spawning and their movement. So let's look right here. We are calling update widgets every single frame of the game. Well, we have a spawn timer, which is going to be in seconds now, and right now we're subtracting 1. Well, we're subtracting 1 every single frame. That's like, we don't want that. We want to subtract time from this. So we're going to subtract off dt instead of 1. And so now our widgets should spawn at a more regular interval. We also need to move our widgets correctly. So let's scroll through here and find where are we moving our widgets. Well, here we're looping through our container of widgets, and right here is our line that moves the widgets. This is very similar to the line we saw where we moved the player. It's the widget's position, and we're increasing it by a speed, but what we're missing is multiplying by that speed by the amount of time we are operating in. So we got to multiply that by dt. Doing that, our widget system should now be back to normal. So we should get 1 widget. All right, so there's our widget. Perfect. There's another widget. Perfect. Oh my goodness, everything is moving so slow though. Well, if you remember, we said the speed of this is now going to be controlled by something known as a difficulty ramp. Quick, I gotta get it. I gotta get it. Can I get it? Drop them in. Whoo, just in time. And look at that. My deadline went back up. I fulfilled my order. My score went up. So the speed of the conveyor belts here and the speed of spawning our widgets is not going to be controlled by a constant anymore. If I go back up to the student edit zone, I believe we commented those constants out. Where are we? Yeah, see, we commented out belt scroll speed. We commented out widget spawn per frames. Instead, we are going to control those with our difficulty ramp. And that brings us to mission number 5. So mission number 5, we're going to set the constants for our ramp system. So let's look at what they are here. So we have ramp time seconds. So our ramp is basically going to determine how long it takes to reach maximum difficulty in our game. If you can survive this long, then the game is peaked in terms of how hard it will get, and it won't get any harder. You just have to stay alive at this point. Right now, it peaks in 35 seconds. For me, that is too short. I'm going to set it to 120 seconds. So our maximum difficulty will occur 120 seconds into playing the game. All right. So where would it be at like our medium difficulty or halfway difficulty? Well, it'd be half that time interval, 60 seconds. Now, during that time from game start to 120 seconds, we are going to scale certain values of our game to make things a little more harder. One of the things that we're going to scale is how many, the maximum number of widgets of a given color that we will allow in an order. So order max per color at the start is currently set to 1. Yeah, okay, that could work. I'm going to change it to 2. So I'm going to say like, hey, you could give, at most, you could get 2 reds or 2 blues or 2 greens. There's no green, 2 yellows. So at most, when you start the game, you might get like, 1 yellow, 1 blue, and 2 reds. You'll never get 3 reds at the start. But by the end of the game, we're going to have it set to be allow 5 of any color. So you could get up to 5 yellows, 5 blues, and 5 reds. You get a huge order. We also are going to control how quick our belt is moving. So look here, our belt, this is pretty funny. At the start of our game, at our easiest level of difficulty, our belt speed is 50 pixels per second. And at the end of our game, our belt speed is 51 pixels per second. Well, those seem really, really off. In fact, we have a note here that we got to make this DT converted. So originally, our belt was moving at 2.5 pixels per frame. So 2.5 pixels per frame, and assuming we are at 60 frames per second, my starting speed should be 150, and that's what the note says right here. It should be 150 pixels per second to start. Now, by the end of the game, at our maximum difficulty, I'm going to have the belt be moving at 450 pixels per second. And then we will set how quickly do we want to spawn a widget. So at the start of the game, our spawn interval, these seem a little bit high to me. I'm going to say at the start, we're going to spawn every 1.5 seconds. And by the end of the game, we're going to spawn every 0.55 seconds. So let's just check this out. Let's see if this at least fixes the slow nature of this game, because now when we start our belt speed, we should be starting at 150. Let's see. All right, and now look here, we actually get up to 2 of each color in our order. So that looks like that works, and yeah, our conveyor belt's working a lot better now. So as we play the game, the longer we play the game, the more difficult this should get. Our belts should be speeding up, our spawn intervals should be going down, and the number that we get of each color in our order could potentially increase, to 3, to 4, to 5, all that good stuff. So how do we actually implement this idea? Well, we're going to go to mission number 6. Mission number 6 finds us in a brand new function called update ramp values. So we know we're calling this every function because we looked at our draw function of the P5 library, which runs every single frame of our game. If we're in our play mode, we update runtime seconds, and then we update all of our functions, right? Ramp, deadline, belts, player, widgets, and order. So mission 6 is about defining the ramp value from runtime seconds. So we got to actually talk, I think, here about what exactly is a ramp. And in order to help us do this, we are going to go to the whiteboard. We're going to bring it out because this is a little bit of a confusing topic, and we're going to explain it here so that we understand the next few missions that we are going to do. So we'll start here by just saying, I'll grab my blue pen, and I'm going to say a ramp is a value, a number between 0 and 1. All right, so maybe your ramp is 0. Maybe your ramp is 0.25. Maybe your ramp is 0.4. Maybe it's 0.5. Maybe it's 8.2 or 0.82. Or maybe it is 1. All right, it's a number between 0 and 1. And so if we think about creating a graph, let's create a graph. Zoop. Zoop. We start, our ramp is on the x-axis. So I'm going to put 0 right here, and I'll put 1 all the way over here. And on the y-axis, we will put something that we want to control via the ramp. So I don't know, maybe I'll put, we'll put belt speed. We'll do belt speed here. So we'll say on the y-axis, we're going to put belt speed. That's something we want to control with our ramp. So our belt speed starts, so right here, it starts at 150 pixels per second, and it ends, what did we say? Its ending speed is 450 pixels per second. So A ramp value of 0 is where we start. That's our starting value. And a ramp value of 1 is our end. So right here, I have 2 points that I can plot. When our ramp is 0, our belt speed is 150. When our ramp is 1, our belt speed should be 450. And those 2 points define a really nice line for me. And I can use that line to adjust our belt speed values. For example, if my ramp were, let's say, between 0 and 1, if my ramp were like 0.5, I would just go up to where this line is and then go across and read out the ramp values. And I don't know what this is. I should know this. We're 300 away. I'll add another 150, so 300. All right, so it could be moving at like 300 pixels per second. If the ramp were over here at like 0.82, we would go up, 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 hit the line and go across and read it. And maybe it's going to be, like 419 pixels per second. The ramp, the value that we pick here, 0, 0.5, 0.87, 0.1, determines the value of the controlled belt speed. So it increases. And this process has a really nice name. This process of creating a line and deriving our values from that line is called linear interpolation. Linear interpolation. And we will use a function called lerp to perform linear interpolation. So the first step, though, is we have to actually go through and build these ramp values. We got to figure out, like, where are we positioned on this x-axis. And so the way we're going to do that, we'll minimize this here, is we have a variable. We have a variable called ramp. All right, and we want to set it equal to some number between 0 and 1. At the beginning of our game, we want it to equal 0, and at our maximum difficulty, we want it to equal 1. Well, thankfully, we have something that's keeping track of how long we've played our game, and that is the variable run time seconds. So when we start our game, that's equal to 0. So that's really great. We're going to take that and divide it by the variable that we set in our ramp constants, ramp time seconds. Ramp time seconds is the time it takes for us to get to maximum difficulty. You see here, it's 120 seconds. So when we start our game, we have 0 divided by 120. Our ramp value is going to be 0, and that puts us right where we want to be on our ramp. It's right here with our starting value. But let's say we play the game for 60 seconds. So now runtime seconds is 60. Ramp time seconds is still 120. That gives us a value of 0.5. So it puts us here on the ramp, a belt speed of 300. And we keep playing. I don't know, let's say runtime seconds becomes 114 seconds divided by 120 seconds. Well, now our ramp value is 0.95, which would put us way over here and get us close to our maximum value. And when we hit 120 seconds, when we've been playing the game for 120 seconds, runtime seconds is 120 divided by ramp time seconds of 120. Our value is 1. We've reached our maximum difficulty, and our belt speed will now be 450 pixels per second. There's only one big problem. If we don't die right then at that moment, runtime seconds is going to go beyond 120. It could get to be like 130 or 140 or 150. And if I make it to 150 seconds, 150 divided by 120 is 1.25. But a ramp has to be between 0 and 1 for linear interpolation. So I have no 1.25 over here. That's not good because a value of 1 is our maximum difficulty. So what we're going to do is we are going to take the constrain function. We are going to constrain our ramp's value. The value that we want to constrain is runtime seconds, tab for autocomplete, divided by ramp time seconds. Again, tab for autocomplete. And its minimum value is 0, but its maximum value is 1. So if it ever tries to go over 1, we will stop it right there. All right, lesson number 6 is in the books. Now, if we look here, we're using this ramp to perform linear interpolation, lerp, on our order max per color variable and our belt speed variable. And if we look here, it looks like our lerp function takes a starting value, an ending value, and a ramp position. So here it is for our belt speed. We pass in our starting speed, 150, and our ending speed of 450, and that defines the line for us. And then we specify where we are between 0 and 1 on our ramp. So that's controlled by, what is it? Our time right here. So if I've played for 60 seconds, 60 divided by 120 is 0.5. So I pass in 0.5 as my ramp. We go right here. The line is drawn for us, and I'm going to read out my belt speed value, and we update that variable. So we're doing that lerping for our maximum orders per color and our belt speed, but we need to also do it for our spawn interval. It says mission number 7, it says use lerp to scale the widget spawn interval. Make widgets appear faster as the ramp increases. All right, so we just got to make sure we target the right variable. I'm going to go to my gameplay variables section. I'm just going to jump up here. I'm going to click. And now I'm in my gameplay variables right here. What do we got to work with? Well, we have our ramp. We targeted that. Orders per max per color, belt speed. Those are already ramp controlled. So I'm going to ramp control my spawn interval seconds variable here. So we're going to update that variable here in mission 7. So spawn interval seconds, a nice old tab for autocomplete, and we are going to set it equal to the lerp function, so we can do some linear interpolation. We got to draw a line, but we got to specify the 2 points of that line. So we need the starting spawn interval seconds, which I believe is a constant of our ramp system. So I'm going to say spawn interval. Ooh, and I get 2 of them. Well, these are alphabetically ordered. One has got start, one has got start, one has got end. So I'm going to do the second one for start, because end would be alphabetically first. And there it is, spawn interval second start. My next point is spawn interval second end. So spawn interval seconds end. And then I got to specify where I am on my x-axis, and that is going to be my ramp. Awesome. So now, as time goes on, as runtime seconds gets bigger and bigger and bigger, my ramp is going to get closer and closer to 1, which is going to push through linear interpolation all of those variables closer to their maximum difficulty values. Let's run this. Let's test it out. All right, so we're playing. I mean, how do I know it's working? I guess. Does it seem like it's getting faster? I guess it's harder to tell. My maximum difficulty is going to come at 120 seconds. So I'm going to play this game for 120 seconds or 2 minutes in order to experience this. Well, one of the things that we can do really quick here is mission number 8. Mission number 8 is about debugging and adding a ramp readout. It finds us in our draw HUD function. So we draw all of our text, we draw the order that we have, but now we have a new mission here. It says draw ramp readout. Display the Factory Frenzy ramp readout near the top of the screen, because we're controlling a bunch of things by slightly changing their data over time. I want to see that data change rather than having to guess whether or not it's working. So if I scroll down just a little bit, we got draw order squares. I have a brand new function here called draw ramp readout. And this is going to show all of my information about our ramp. The ramp's percentage, the belt speed, the maximum number of orders I can have per color, and our spawn interval. We're going to create text that shows that to us. And while we're building our game and debugging our game, I want to read that text. So right here in mission number 8, I am just going to call that function draw ramp readout. Tab for autocomplete, parentheses to call it. And now that I have that there, I have access to all of the information in my ramp. So I can see it changing in real time. And then once we're done with the game, we will just comment that line out so we no longer see the ramp. All right, so my ramp is getting higher. All right, it's at 6% right now. The belt speed is moving faster and faster and faster. Right now our maximum order number is per color is 2. Our spawn interval is 1.36. Let's see if we can get some of these to increase. I'd like to see the maximum color order get to, say, 3. All right, so we're at 23% here, 25%. All right, now I can have a max order of 3. I just got to complete this order. I got to get me some blues. All right, there's a blue. Let's put it in. All right, let's grab another blue. Hello, blue. There it is. So now we should be able to get some 3s here. Oh, and I didn't. Well, it's not guaranteed that I'm going to get 3s. So let's just keep playing here. All right, and there's another order coming through. Okay, and so now I have those 3s there. Things definitely feel like they're moving faster. I'm having a harder time keeping up with the game. The belts are moving faster. The widgets are spawning faster. It is definitely getting a little bit more hectic, which is exactly what I want out of this game. So I think our difficulty ramp here is working really, really nice. So we did a lot of great stuff here in this video. We took what was an inconsistent gameplay, depending on what computer you were playing it on, and we made it consistent by switching from frame-based operation to time-based operation. And in doing so, measuring how long we've played the game, we use that time to create a difficulty ramp through linear interpolation. So our difficulty just scales. It gets harder and harder and harder the longer we play our game. Our belts move faster, our widgets spawn faster, and our orders grow in size. So I think this is a great place to stop, and I'll see you in the next video.